The purpose of this video is to describe how to perform analysis on standard operating procedures. We'll look at this in 3 steps. 1. How to model SOPs. 2. How to evaluate SOPs. And 3. How to simulate and analyze SOPs. Thanks everyone for getting together on short notice. The release of this embedded Zoom link feature on the calendar app is not going well. This SOP is simply proving problematic for the end users. We're getting a lot of online and call center complaints, and product downloads are way down. In fact, it looks like 20% of the users are having problems. As you know, we already tested many times. In fact, we've tested every possible situation that could occur. The software should be bulletproof, yet we're getting all these complaints. What if the software works perfectly but the users don't perform their end of the interaction reliably? We need to make sure that the interaction between software and its end users is seamless. So as a team, we now need to figure out how the end user interacts with the software. Okay, let's start with a storyboard of the user interfaces. The task we are looking at is to create an Outlook calendar meeting invite with an embedded Zoom link. The user has 7 steps to complete in this task. Step 1. Click on a New Event button. Step 2. Click on a camera icon. Step 3. Click on Add a Zoom Meeting menu item. Step 4. Click on Allow. Step 5. Enter company domain GMU. Step 6. Click on Continue. And Step 7. Enter date, time, invitees, agenda, etc. Now let's look at these steps one by one on the application. First, on the calendar screen, the user clicks on a New Event button. Then, on the New Event screen, the user clicks on a little camera icon on the upper right corner and selects Add a Zoom Meeting from the drop-down menu. After that, Outlook asks if the user would allow Zoom to display a new window. The user clicks on the Allow button. On the next single sign-on screen, the user types the domain name of the company and clicks on Continue. Now the user can enter the details about the meeting, such as meeting name, date, time, invitees, etc.
Can I show my screen? I modeled the design in an MBSE tool that I would like to review with you. Note that it's important to distinguish between the actions taken by the user, such as clicking on a button or typing an entry, and the decisions made by the user to perform the actions. To better illustrate this, we can organize our steps in a table like this. Very few users fail to perform the user actions such as click or type entry once they have decided to perform the action. It is possible to mistype an entry or click an adjacent link, but most users will notice the slip and correct right away. The problem with completing a task occurs with the see, remember, and decide. Human operators can reliably decide when they are cued by visual or oral or haptic cues. If the design of the system does not provide visual cues, then the human operator must decide by remembering to perform the action. The human brain, as amazing as it is at recognizing patterns and reasoning, is very bad at remembering. So any design that does not visually cue the next decision and requires the human to remember is subject to poor reliability. This is especially the case for remembering rare events. Remembering can be from long-term memory or from working memory. Remembering from long-term memory occurs when you learn how to perform a task in a classroom and then how to perform the task in the field, say 3 months later. Remembering from working memory occurs when you are provided information at one step in the task that must be used several steps later in the task. So we know that each decide is made up by see or remember. Now we need to understand how good the see or remember cues are. An SOP can be evaluated by assessing the cues that prompt each step in the task sequence. There are 2 basic types of cues: external cues from the environment, like the software application user interface, and cues from memory, either long-term memory or working memory. The basic design rule is don't make the operator have to remember. Do not design the system to require the user to have to recall what to do next from memory. Make sure to design salient, unambiguous, and visual cues for each operator step. Let me flip to the next screen and show you the cue evaluation matrix that I put together. Each cell in the matrix represents the combination of cue properties and the frequency with which the cue is used. The cue properties range from no cue at all to cue in field of view, salient, and strong semantic match. The frequency ranges from every day to once a year or less. The cells in the matrix are color-coded, indicating reliability. Steps in the task that are green are most reliable, and steps that are red are the least reliable. The cells in the matrix also include a triangular distribution of how long it takes in seconds to complete a step in a task with the frequency cue properties pair. These distributions are derived from experiments with hundreds of users and represent a user population. You notice how much longer the times are in the cells in the upper right-hand corner that represent the rare events that occur in the absence of visual cues. These are the ones where we mostly rely on memory and include the thinking and deciding times. They might also include incorrect entries and backtracking. When tasks are done every day or up to once a month and are cued by salient, unambiguous, and visual cues, humans can do them very quickly. This is represented by cells in the lower left. Now let's evaluate each of the 7 steps in the process using the cue evaluation matrix. It does not take long to see we have 4 problematic steps. For step 2, the use zoom function, the visual cue is a tiny camera icon tucked into the upper right corner of the screen. Will most users look in that location? Will most users recognize it as an icon for zoom? For step 4, safe to allow zoom to open window, the cue is clear, but how will users know if it's safe or not? With all the cyber awareness training we get, will some users want to be safe and not click on the allow button? What are the criteria a user would use to determine if it's safe, and how would a user know? For step 5, enter the company domain name. How many users know their company domain name? How many will know it's an acronym and not the full name? For step 7, enter meeting date, time, and invitees. The user must recall from memory the invite instructions that kicked off the task. The trigger event for the task, an email, requires the operator to put all the meeting details into working memory. This information must be held in working memory until it's used in step 7. As you will see, this information must be held for approximately 30 seconds. This is way in excess of the 10-second rule of thumb for working memory. In summary, of these 4 steps that are troublesome, 3 of them require remembering from long-term memory. 1 step requires remembering data put in working memory from step 1 and used in step 7. So a number of questions to think about. How long do you think these steps should take? What's the probability that the task can be completed in less than 35 seconds? Which steps are most likely to be problematic to users? I assigned the time distributions from the cue evaluation matrix to the MBSE SOP action diagram that I showed you earlier. I set the design time during the task to take less than 35 seconds. Now let me show you the results of the simulation. This Gantt chart shows the waterfall sequence of steps. The length of the blue line shows the average duration for each step. Notice how steps 2, 4, and 5 exhibit the longest completion times. Steps 1, 3, 6 are performed quickly in a reliable manner. The performance is the result of the triangular distributions used in the model from the Q evaluation matrix. I did not model step 7 in this simulation. The designers assigned a maximum of 35 seconds to complete the task. This is known as the Available Operational Time Window, or AOTW. These charts show the time distributions for 5,000 different users from a Monte Carlo simulation. The blue chart shows the time on procedure, or TOP. The TOP averages 29 seconds with a 6-second standard deviation. The maximum TOP is 44 seconds, which is 9 seconds over the design target of 35 seconds. The results show that there is a 20% probability that users will not complete the task within the 35-second design target.
That number is pretty much the same as the reported percentage of users having trouble with the app. Looks like we found the reason for our problem.